Good morning, everybody. My name is Hamza Baniata, and I'm going to be presenting my short paper on fog-enhanced blockchain simulation. I'm a PhD student in the Department of Software Engineering at the University of Sikkim. Through my presentation, I will give a brief introduction. I will discuss the related works, and I will discuss the phases of my research. And then we will discuss the proposed blockchain fog simulation environment and show a case study that we conducted and conclude the presentation. Blockchain is a technology proposed in 2009 initially as the basis of Bitcoin, providing a secure and trusted third-party free distributed ledger, whose data is being confirmed by achieving a consensus on their validity. As presented in the figure, all blockchain nodes receive the generated transaction, validated, and later added to the chain. Blockchain provides high security and trust measures as it is almost impossible to alter or modify data on the chain unless the majority of participants agree to the modification. The distribution of BC nodes who don't know each other guarantees the security of no middling authority, such as a bank administration. Blockchain had been used for different purposes, mainly categorized into four domains. It had been used for data management systems, reputation management systems, access control, and trading and payment measurements. To reach a consensus on a piece of information validity in blockchain, a user generates this information, named the transaction. The network then verifies the identities of the generator and receiver. Blockchain nodes, also named miners, work on verifying the transaction by checking if the generator satisfies a specific criteria defined by the algorithm. Miners also work on solving a mathematical problem named a puzzle, for this solution is a proof of their work. This is why this algorithm is named the proof of work. Among many variations of proof-based algorithms, the proof of work is the most used so far. Once a miner achieves a solution, it compiles all the valid transactions in one block and broadcasts it to other BC or blockchain participants. These participants confirm the block by validating the solution and adding it to the locally saved chain. Cloud computing is a paradigm that had been used for years now to perform computational communications and storage services for end users. However, cloud servers are distributed in different regions around the world whose latency for some delay-sensitive applications cannot be tolerable. Hence, fog computing was proposed in 2013 by Cisco as the extension of the cloud at the edge of the network. The decentralization of fog computing uh, components near the end users' nodes provides secure and reliable cloud services while enhancing the latency of the cloud. So my research goes into two main phases. Phase one includes implementing a blockchain simulator, and we actually accomplished this successfully and used the blockchain simulator in validating a published paper and or a proposed idea, and we published the paper in the Closer conference held in Prague in May, and the paper now is published. The second aim was to comprehensively survey blockchain fog integration approaches, and we also achieved this successfully. And we got really interesting findings, and we published the paper in a Q1 journal, which is the IEEE Access. Um, And for the second phase, um, it aims to develop the simulator and integrate it with fog computing environment that would make it easier for non-practitioners to use the simulator. So it will have a graphical user interface, and it will give wide options for the user to use the simulator. And it mainly uses the findings and the codes that we implemented in phase one. So please go ahead and check these two papers, and I would really appreciate any feedback or questions regarding them. We investigated the current research trends in the fields of blockchain, Internet of Things, and fog computing, and found that the international research effort aiming to enhance the blockchain technology had been even greater than research efforts given towards IoT. However, compared to the IoT, the fog computing research effort is not given this good attention. To be specific, since 2015, research targeting blockchain integration in the Internet of Things paradigms had been significantly higher than blockchain integration in the fog computing architecture. This is clarified with number of published research papers concerning the two domains presented in the figure of the slide. So, according to the pool research effort towards integrating blockchain and fog computing technologies, we decided that we want to conduct this survey. And we searched for all papers that are concerned with fog computing and blockchain, and we categorized them according to the year of publish of the papers and the surveys. And you can see the numbers provided in this figure. For the specific and technical details we found after comprehensively studying those papers, we direct the respected listener to refer to our survey. But in general, we found that um, the vast majority of blockchain integration in a fog computing environment aim to use the blockchain for data management purposes rather than trading or reputation. Also, some researchers use the blockchain for identity purposes or access control, and the least majority used the blockchain for reputation purposes. We also categorize these integration approaches according to the consensus algorithm used in the blockchain. And we found that most of the researchers or the integration approaches use the proof of work, and the other types of proof-based algorithms were used, but not as much as the proof of work. Now, some other consensus algorithms that were used for permissioned or private blockchains, such as the BFT or PBFT, were also used, and we deeply discussed this during the survey. We also categorized the research that, or the integration research papers that we studied according to the layer where the blockchain was implemented. As discussed in the introduction, a cloud computing paradigm includes three major layers, which is the cloud layer, the fog layer, and the end users layer. And we found that even in specifically a blockchain fog integration approach, most of the papers implemented the blockchain in the cloud layer because many of them use the blockchain for trading purposes. And when using the blockchain for this purpose, then it is concerned in the cloud. If we didn't assume this, then the most used layer for the implementation of the blockchain was the fog layer. So to validate our implementation, we performed multiple simulation runs to this implementation code to mimic the blockchain validation, and we performed these experiments on the computer with specifications presented here. And as can be seen in the figure, um, we just generate random numbers and then try to validate the existence of this number in a block, in a chain or a database that is saved in the RAM and in the hard disk. And accordingly, we got some results. In the first case, we wanted to compare the time consumption of blockchain validation and confirmation while the chain is saved on the RAM and saved on the hard disk. And as we can see in the figure, saving the chain on the hard disk consumes almost 7 minutes to confirm one block, while it's almost 0 seconds to confirm a block while the chain is saved on the RAM. So we performed this simulation on our code and we got these results. In a second case, we used our simulation to mimic the blockchain validation and confirmation, aiming to assess the consumed energy by the whole system. And according to our simulation run and our code, we found that using less number of nodes validating and confirming blocks would consume a lot of energy or a lot less energy uh, compared to a chain or a blockchain system that uses a proof of work consensus algorithm. As a conclusion, we are researching the integration of fog computing and blockchain technologies. We conduct our research in two phases. Phase one of our research is already done, and we discussed this and showed that we published two different papers regarding this. And we will be using our findings in phase one and the implementation codes into the second phase to provide a user-friendly, comprehensive, fog-enabled blockchain simulation environment. Thank you so much for your attention. Please refer to this email if you have any queries or notations. I would really appreciate your feedback. Thank you.